So we're doing amount of substance, mole calculations and mass calculations. We're now on to mole and mass, in which we're going to define the mole, redefine it, interconvert mole and mass, and then derive this formula: mole equals mass divided by mR, which is kind of the crucial equation which you need for all these mass calculations. So just to review what we were doing last time, we were weighing the carbon atom, and we found it didn't weigh very much. But if we added enough carbon atoms so that it weighed exactly the same as its relative atomic mass, then that came out as this number of carbon atoms: 6.022 times 10 to the 23, a big number, a large number, and that's called Avogadro's constant, that number, and it's also called a mole. Okay, so we want to interconvert mole and mass, and we know that the relative atomic mass of the carbon-12 is exactly 12. This is what we've just said. If we put 1 mole of carbon atoms on the scale, it will weigh exactly 12. Well, let's now think about hydrogen. Hydrogen's relative atomic mass is 1.008, so we know that the mass of each hydrogen atom relative to carbon is 1.008 relative to 12, so about a 12th. So if we then were to put on the scales lots of hydrogen atoms, in fact we'll put on exactly this same number of hydrogen atoms, 1 mole of hydrogen atoms, then the question which we're thinking about is how much will this weigh? Well, we know that this ratio between individual atoms is 12 to 1.008. So if you scale everything up, and that's all we've done here, we've scaled everything up, just instead of having one atom, we've got a mole of atoms, 6.022 times 10 to the 23, then this mass is going to be 1.008, i.e. the same as its relative atomic mass. And we can apply this to elements where you have isotopes present. So for copper, we know we've got the 63 and the 65 isotope, I think it is. So anyway, it has a relative atomic mass of 63.55. So if we then put on 1 mole of copper atoms, then in there you're going to have a mixture of each of the isotopes, but their proportions will be such that the actual mass of this will come out as the relative atomic mass, 63.55. We can do this for molecules and compounds as well. So for water, MR is 18.0186. Just think of it the other way around. If we therefore have 18.016 grams of water, that will correspond to 1 mole of H2O molecules. So our conclusion here is that 1 mole of a substance weighs its MR. Okay, so if we go on to some examples, if I have 1 mole of copper, what mass has this? MR 63.55, therefore mass of 1 mole, 63.55 grams. If we go to what's the mass of 1 mole of CuO? MR CuO, we've got to add the copper and the oxygen, which gives 79.55, so 1 mole will weigh 79.55 grams. So we could think of this as a ratio of mole to mass. If we have 1 mole, its mass will be the MR, which helps with questions like this. What's the mass of 0.23 mole of copper? Well, 1 mole will be the MR, so 1 mole of copper, 63.55 grams. 0.23 grams to 0.23 mole will be that MR multiplied by 0.23, which gives 14.62 grams. So we've maintained this ratio of 1 to 63.55 is the same ratio as 0.23 to this 14.62. And you can do it the other way. So if I have 10.6 grams of copper, how many mole of copper is this? So we know 1 to MR is our mole to mass ratio. For copper, this is 1 to 63.55. Now you can sort of invert this. So we now say 1 gram would be 1 over 63.55 mole. In the question we are talking about 10.6, so there's 10.6 grams, so therefore we'll have to multiply that point by 10.6, and 10.6 multiplied by 1 over 63.55 is 0.167, so we have 0.167 mole of copper atoms. Okay, so now let's derive this formula: mole equals mass divided by MR. Let's think, how do we get the mass from the number of moles? Well, if we've got 1 mole, it's the same as the MR. If it's 2 moles, it'll be twice the mR, so we just multiply the number of moles by the mR, i.e. the mass is the mole multiplied by the mR. Now I can put this into a triangle to say that the mass here is equal to the mole multiplied by the mR, which is a useful way of thinking of it, because now we can therefore say that mole is equal to mass divided by mR, which is our equation there. Mole is mass divided by mR. Of course, you could go from mR and say mR is mass divided by mole. Okay, and let's kind of think of it in a slightly different way from the point of view of mR. We could say that mR has a unit of grams per mole. It's how much a mole of substance weighs. mR is grams per mole. Grams is a measure of mass per mole, mass divided by mole. That's what we see, mass over mole. Just another way of thinking of it, which might help you remember it or be able to work it out. Okay, a couple of questions here for you to think about. I'll put up the answers in a few seconds.